Hello, good morning. Can you now hear me? Hello, good morning. Can you now hear me? Hello, good morning. Can you now hear me? Hello, mic test. Wala na bang echo? Hello, mic test. Wala na bang echo? Okay, great. Sige, so, okay, great. Sige, so let's begin our lecture this morning. So again, I apologize for the inconvenience. For some reason, my mic was not detected earlier. And so I have to, and then there is a pop-up from Facebook that tells that there is an error in the rendering of the audio. And so I have to restart. It advised me to restart the whole thing, whole system. And so I apologize for the inconvenience that this has brought to everyone. So yes, so without further ado, let's begin our lecture. Okay, so our first lesson this morning is going to be about water hammer. Okay, so one of the phenomenon in hydraulics in a pipe system is the water hammer. Okay, so this is a phenomenon that occurs in hydraulic systems when there is a sudden change in the flow rate of a fluid, causing a pressure wave to propagate through the system. Okay, so let me show you a figure so that you'll understand what I'm talking about. Okay, so we have here a tank. Okay, and then attached to it is this pipe, and then there is a valve here. Okay, and of course, water will drain, and then it will enter at point A at a certain velocity. Now, if we're going to suddenly close this valve, now from its flow that is high pressure, of course, it's not possible, not realistically, for this valve to be closed like almost instantaneous. But let's just say theoretically, now we were able to close this valve instantaneously. And so, due to that sudden change in the rate of flow of the fluid, there is going to be a pressure wave that is going to be propagated throughout the system, which would cause damage to pipes, valves, and other components of the system if not properly controlled. Okay, so This is a figure of a pipe that's broken due to water hammer. Ayan. So, dahil nga sa pressure no na sobrang lakas, and then if you close this, for sure there is going to be a build up of pressure or energy dito sa pipe natin, and then if not controlled properly, so bigla talaga tong uh, bibiyak no or magbe-break yung ating pipe. Okay? If hindi siya makontrol na maayos. And so why do you think is it called water hammer? Sige, so let's have a little interaction. So why do you think is it called water hammer? Sige po, paki-type sa comments or sa Padlet natin yung idea nyo bakit kaya siya tinawag na water hammer. Or sa Padlet natin, idea nyo bakit. Anyone? Bakit kaya? Bakit siya tinawag na water hammer? Sudden change of pressure, sir, according to Kyle Joshua. So correct, that is the cause no of the water hammer. That's the description of the water hammer phenomenon. Pero why do you think, I mean, I'm talking about the name. Hammer ba? Martilyo. Eh, wala namang martilyo tayong nakikita. Wala namang martilyo sa analysis ng system natin. May pressurize kapag biglang pipigilan ang pagdaloy ng malakas na tubig. High pressure pound the pipe, sir. Ayun, tama, no? So, due to the pressure that is propagated in the system, when there is a sudden change in flow rate, so magkakaroon ng pounding or pagpukpok no, doon sa mismong pipe natin. And although this phenomenon no, is very less natin likely na encounter every day, dahil nga sa design ng mga valve natin na hindi naman talaga instantaneous no yung pagsara ng mga pipe natin. And so wala tayong napapansin masyado or na-experience sa mga ganitong phenomenon. So kaya pero if there is mangyayari siya kapag meron tayong valve na talagang instantaneous in a split second no, ma-close yung valve. Okay, so bakit nga ba natin siya kailangan sa ating civil engineering? Of course, kasi we want to make sure that there is efficient pipe distribution or water distribution no, in our networks. Okay. Sige, so let's proceed. Okay, so to measure the speed of the pressure wave generated no, in this phenomenon during a sudden closure of fluid in a pipe, Meron tayong tinatawag na celerity. So celerity is the speed of the pressure wave in meters per second. Okay, so yung formula ng celerity, that is equal to the square root of the Bock modulus of elasticity of fluid, that is denoted as E subscript B. So the subscript B there refers to the Bock modulus of elasticity over the density, that is kilograms per cubic meter. Okay, so if we're going to do unit analysis on this one, okay, so we have here the Bock modulus of elasticity, that is in terms of Pascal. So alam naman natin yung Pascal, that is kilogram meter per square seconds. Tama? Okay, and then our density, that is kilograms per cubic meter. So magka-cancel si kilogram. Okay, and then magka-cancel si meter sa taas. Ito, square na lang yung matira, no? So you'll have m squared over s squared. And since square root yan, diba? Square root yan. So what we'll get is in terms of meters per second. Okay po. So meters per second ang unit ng celerity. Okay. So importante po ang unit analysis. Okay. So for non-rigid pipes, ito yung mga pipes, no, na flexible, na bend. Ayan. So iba naman yung formula for non-rigid pipes. So we have celerity pa rin. Then the same formula, pero our Bock modulus of elasticity is in terms of subscript C. Okay, so yung subscript C natin stands for composite modulus of elasticity. Okay po. So, in terms of Pascal pa rin siya. Okay. So, anong relationship ng ating Bock modulus of elasticity and our composite modulus of elasticity? So, ito lang, no? It is described by this relationship, that is 1 over the composite modulus of elasticity of the fluid equals 1 over modulus of elasticity, that is Bock modulus, plus the diameter, internal diameter of a pipe. Okay po. And then, we have here the E, the modulus of elasticity of the pipe of the material times the thickness. This is supposed to be E times T. Okay po. So, you just simply solve for E sub C. Let's say given tong other parameters, and then substitute mo lang dito. Okay? Okay, now let's say we want to evaluate the time required for the pressure wave to travel from the valve to the reservoir and back to the valve. Okay, so again, ito yung ating figure. So sabi dyan, yung oras daw para mag-travel yung pressure wave galing sa valve and then punta siya sa tangke o sa reservoir and then balik ulit siya doon sa valve. Diba, that is bale back and forth, no? So 1L then 2L. So bale galing lang to sa formula ng distance equals rate times time. D is equal to R times T. Divide both sides by R. So T is equal to D over R. Ayan. So yung distance traveled, no, as described here is twice the length, no? Let's say ito yung L natin. Ayan. Yan yung L. So twice ng length natin, yan yung distance traveled. And then the rate at which the fluid is moving is yung celerity natin, no? That is 2L over C. And then, meron category ng closure ng ating valve. So, meron tayong tinatawag na rapid closure. Okay, so that is if we compare or if our time of closure is greater than the time for the fluid to travel, no? Or the pressure wave to travel, that is T, yung 2L over C. So, pag mas malaki yung time of closure compared sa time of travel, that is considered as rapid closure. So, yung formula natin is P sub H, that is referring to the water hammer pressure, that is equal to the density of the fluid times the celerity times the velocity. Okay po. So if we're going to analyze the system, the units, diba, density, that's kilogram meter per square second, and then celerity natin, that is meters per second. Velocity is also meters per second. Wait lang, may nagtatanong. Hindi maka-join sa Padlet. Wait lang. I'm not sure about that. Pero I'll ask later during the break. Okay po. Sige. So, let's analyze the units later. Pag nag-solve na tayo ng problem. Okay, and then for slow closure, that is when TS is greater than 12 over C. So this first one, that is supposed to be less than. Let me just correct that. So, kapag greater than yung time of closure, so iba naman yung formula, no? That's P prime times H equals 2L times density times the velocity over time of closure. Yan. So, yan lang yung mga formula na tatandaan natin for water hammer pressure. So, again, pressure yung mini-measure dito sa mga formula natin. Okay, so let's have our first example. Problem 24. So oil with specific gravity equal to 0.85, bulk modulus 1723.75 megapascal is flowing in a 2,500 long rigid pipeline with a diameter of 600 mm at 0.65 cubic meter per second. So first question, if a valve is located at the end of the line, what is the minimum closure time in order to avoid a maximum pressure surge? Okay, so bale yung hinahanap sa tanong na to is time. No, minimum closure time. In order to avoid a maximum pressure surge. Okay, so kailan ba nangyayari yung maximum pressure surge? Nangyayari po yan kapag yung ating fluid, no, was able to travel twice the length. No? So, kaya ito yung formula natin. T is equal to 2L over C. Okay, where celerity, again, is equal to the square root of the bulk modulus of elasticity over the value of our density. Ayan, so since we can't solve, given naman yung length, diba? Ito, given to. Ayan, so ito yung wala. So solve na natin si C. So do we have the bulk modulus of elasticity? Given ba tayo? Meron. Do we know the density? Okay, meron tayong specific gravity. So, pwede nating ma-solve yung celerity. So, let's do that. So, ito yung celerity natin. Again, square root yan ng... Okay, sa numerator, ilagay natin yung bulk modulus of elasticity. Ayan, so express natin sa Pascal. That's 1,723.75 times 10 raised to 6. So, remember, 1 megapascal is 1 million pascal po. No, kaya yan times 10 raised to 6. Okay? Over the density. If you still remember, no, yung relationship ng specific gravity, that is equal to density of fluid over density of water. So if you want to know the density of fluid, it is simply equal to, plus multiply mo lang to. So given yung specific gravity na 0.85, multiply natin sa density of water na 1,000. And so of course, meron tayong density ng fluid. Okay, so that is equal to 0.85 times 1,000 is of course 850. Okay, so that's 0.85 times 1,000 for density. So what is the value of celerity? By the way, sa Padlet, nakalagay na in advance yung option for the Q&A. So if ever meron kayong mga tanong for consultation, so it's much better if it's given in advance, no? So I'll just leave the link open and then kindly give your questions in advance. Okay po. Para mas masagot natin ng mas detalyado mamayang gabi. Sige, anyway, so what's your answer? Celerity is how much? Okay, so that's 1,424.06 meters per second. So tama yung mga sagot sa chat box. So now that we have celerity, we're now ready to solve for the T, no? Which is the time that is required to avoid pressure surge. Kasi kapag greater than 2L over C, so magkakaroon na ng water hammer pressure. Sige, so substitute lang po natin. So T is equal to 2 and then the length given, that is 2,500. Ayan. And then celerity, that's 1,424.06. Sige, so what is the value, or what is the answer for the first question? Okay, so the answer is 3.51 seconds. Ayan, so pag lumagpas na ng 3.51, so magkakaroon na po tayo ng water hammer surge na maximum. Okay. Next, letter B. So find the water hammer pressure developed by closure of a valve at the end of the line if the closure time is 1.8 seconds. Okay, so binigyan tayo ng TC, no? Closure time. Yan yung ibig sabihin ng T sub C. So closure time is 1.8 seconds. So compare lang natin yan sa 2L over C. So yung 12 over C, na-compute na natin, which is 3.51. Okay, so let's make the comparison. Is 1.8 less than or greater than 3.51? Okay, so obviously, that is less than, correct? Ayan. So ibig sabihin, our in our first in this situation, no, rapid yung closure kasi mas mabilis. Tama. So kapag mas mabilis po, formula natin, water hammer pressure is density times celerity times V. Sige, so let's do this. So, meron tayong density na ano na natin kanina, yung density natin. Density, no? Meron na ito 0.85. Ang problema celerity meron na din. So, yung velocity na lang. So, solve na natin yung velocity, that's Q over A. Meron tayong Q. So, meron, no? In terms of ano na tayo, cubic meter per second. So, no need to hindi na kailangan na convert. So, naka-cubic meter per second na siya. So, diretso, 0.65 divided by yung area natin. So, take note, diameter natin is 600 mm. That is simply pi over 4 times the diameter 0.6 squared. So, magkakaroon po tayo ng velocity. So, what is the velocity? So, velocity natin is 2.3 meter per second. Tama. So, now na meron na tayong velocity, so substitute na lang po natin. So, that's water hammer pressure is equal to, okay, so yung density natin, that's 0.85 times 1,000 or 850 times yung celerity natin na 1424.06 times our velocity, which is 2.3. So, what is our water hammer pressure? Okay, 2.78 times 10 raised to 6. Or that's 2,784,037.3 pascals. Okay, answer for letter B. So, medyo ano yan, malakas, no? Because imagine, very instantaneous naman, no? 1.8 seconds. So, talagang magkakaroon ng pressure, ano yan, pressure wave na sobrang lakas. Okay, so ano bang unit nitong density? So, yung density natin, naka-kilogram per cubic meter. Yung celerity natin, that is meter per second. And then yung velocity, that is also meter per second. Okay, so magkakaroon tayo ng squared. Ito makakancel, no? Magiging m na lang to. Okay, so that's kilogram per m times 1 over s squared. So that's basically kilogram times meter per square second. Which is equal to Pascal, di ba? Pascal is Newton per square meter. So, yung Newton, if i-ano mo yan, that is kilogram meter per square seconds over m squared. Okay, so, wait lang. So, this is kilogram per ms squared, no? Which is equal lang siya dito. Kasi makakancel tong isa eh. Cancelin to. So, you'll get kilogram per meter per second squared. So, equal nga lang sila. Sige. So, dinouble check ko lang, no? Yung units. So, tama yan. Next, for letter C, find the water hammer pressure developed by closure at the end of the line if closure time is 6 seconds. Sige, so if closure time is 6 seconds, is it less than or greater than our T, no? Na na-solve natin earlier. Same po ba sila? Okay, so of course, it's less than, no? Less than yung sorry, that is greater than. Time of closure is greater than 2LC. So, mas maliit yung T, ano natin? Yung T, yung 2L over C. Yun. Diba? 6 is greater than our 3.51 seconds na t. So therefore, slow yung ating closure. So ibig sabihin yung formula natin is yung p prime h equals 2 times length density times velocity over the time of closure. So isa-isa natin. So p prime h is equal to 2 times your length, which is 25, times yung density natin, which is 850, times yung velocity. So, do we have or do we know the velocity? Meron, no? So, ito yung 2.3 divided by TC. So, time of closure natin, 6 seconds. So, what is the water hammer pressure? Okay, so water hammer pressure is 1,629,166.67 Pascal. Or that's 1.63 times 10 raised to the power of 6. Okay. So if i-check natin yung units nito, no? Check lang natin out of curiosity. Okay, so yung length natin, 'di ba, naka-meters 'yan. Ayan, so yung density natin naka-kilograms per cubic meter. Velocity natin naka-meters per second. Divide mo 'yan sa time na naka-second. Okay, so bale, ganoon pa rin, no? So ito m squared, and then ito m na lang. And then ito magiging s squared. So same pa rin kanina. Kilogram uh, kilogram over ms squared. Which is equal yan sa Newton per square meter. If i-expand mo to, no, maka-cancel din yung ano, yung magiging kilogram per meter per second square din siya. Same lang sila ng sagot. So, Pascal pa rin, no? Ayan. So, yan yung mga sagot natin. You can take a screenshot if you want. So, yung PDF, i-upload ko ngayon lahat ng sections, lahat ng weeks so far. So, apologies lang sa delay kasi inaaral ko pa, no, yung kung paano. Magpapaturo pa ako. Okay, so may tanong po tungkol sa problem 24. Any question po? Yes, binago ko na yung sign. Sir, di ko makuha unit ng C na meter per second. Bakit? Di ba yung book modulus of elasticity, ano yan eh, Pascal. Sige, i-derive natin. Di ba yung book modulus of elasticity Pascal, so that is Newton per square meter. And then yung baba, kilogram per cubic meter. So yung Newton, 'di ba, that is kilogram meter times meter per square second divided by m squared. Tapos kapag dinivide mo siya sa kilogram per cubic meter, ibig sabihin multiply mo siya sa baliktad niyan, 'di ba? Inverse. Magiging ganyan siya. Tama? So magka-cancel si kilograms. Okay, yung m cube tsaka m squared magka-cancel. So isang m na lang to, no? So bali, pag multiply mo yan, magiging m squared over s squared. So since naka-square root yung formula, so ibig sabihin meter per second. Di ba po? Ayan. So, hopefully na-address ko po yun. Yes, nagkabaliktad lang yung pagkalagay ko. Okay, Facebook, wala ng question. Okay, so regarding sa frequency ng paglabas dito sa board exam, very, ano siya, no? Very madalang siyang lumalabas sa board. Yung question na lumabas ata sa board exam recent is yung definition mismo ng water hammer. Ayan. But who knows, no? Baka yung concept o yung mga formulas natin, baka itanong na, no? This time around. So, better na well-prepared tayo in any eventuality. Yes, baliktad yan. Di ko pa ba nabago? Less than. Okay, naghahang yung ano ko. PowerPoint for a while. Sige. So, while nag-load siya, magbabasa ko ng mga question. Sir, ask lang yung orifice, mag-continue pa rin mag-discuss. Yes po, after the second example, diretso tayo sa orifice. Yun. Sige. Sige, you can take a picture if you want. Nayos ko na yung less than. You can take a picture if you want. Nice po na yun. Baliktad pa rin ba yun? So yung rapid natin, ito yung less than. Yan, so yan na yung final na sagot. So you can take a screenshot if you want. The count of 3. 1, 2, 3. Okay, so let's proceed. Okay, so kanina rigid steel pipe yon. So next example natin is non-rigid na steel pipe. Okay, so a non-rigid steel pipe, 600 millimeters in diameter, is to carry a maximum static head of 350 meters of water. So given tayo ng static head. And additional pressure due to water hammer when quick closing valve stops at a flow of 0.85 cubic meter per second. The pipe has a thickness of 18 millimeters. Bulk modulus of elasticity is 2068.5 megapascal. We're given the modulus of elasticity, that's 200 gigapascal for steel. So the question is, what is the composite modulus of elasticity of steel? So obviously, since this is a non-rigid steel pipe, so hindi na po mag-apply no yung E sub B. Rather, it is going to be the E sub C, or for bulk modulus, stands for bulk modulus of elasticity. Okay? So, substitute lang natin, no? We need to find EC. So, that's unknown. Equals 1 over, so yung bulk modulus of elasticity natin, that is 2068.5. Ito yun, no? Megapascal. Plus, okay, so yung diameter natin in terms of D, in terms of millimeters, that is 600 millimeters, divided by the modulus of elasticity E, that's 200,000 gigapascal, times yung ating thickness, that is 18 mm. So, paki-shift solve na lang po. Okay, so the composite modulus of elasticity is okay, so that's correct. That is 1538.204. Okay, for a while lang, naghahang ulit si PowerPoint. Okay, so answer is 1538.204. So yan na po yung sagot natin for letter A. Next, letter B. So we're asked to solve for the water hammer pressure. Okay, so first we need to check if our flow is actually, I'm sorry, if our time of closure is less than no yung sa T, yung time for to avoid maximum pressure surge. If you're going to look at the question, okay, so it states that there was an additional pressure no, due to hammer that is it stops at a flow of 0.85. So ibig sabihin it was applied no with rapid closure. So ibig sabihin we're going to use the formula for water hammer, that's density times celerity times velocity. Okay, so our density of course that's water, so that's 1,000. And then yung celerity natin, that is given, no? Bulk modulus of elasticity. Sorry, this is EC, no? Kasi ano tayo, naka non-rigid. So EC yung ilalagay natin, that's 1,538.20. And then this is in terms of Pascal, kaya times 10 raised to the power of 6. Okay, over the value of the density. That's 1,000. So yan yung formula ng celerity, if you still recall. So again, that is EC over, square root of EC over density. Times yung velocity po natin. So to solve for velocity, so of course, that is Q over A. That's 0.85 over area natin, that's pi over 4 times 0.6 squared. What is the value of the water hammer pressure? So water hammer pressure is 3.73 no, times 10 raised to the power of 6, or more exactly, 3,728,483.947 Pascal. So yan po yung water hammer pressure based doon sa given. And then letter C, what is the maximum stress acting on the pipe? Ayan, so this is anong formula dito? Maximum stress. So, formula ng thin-walled vessel, no? Thin-walled kasi ano lang, 600 mm. Ay, yung thickness 18 mm lang. So this is sigma T. That is PD over 2T. So ito yung formula natin for maximum stress. So solve natin yung density or yung Hindi yan density, that's pressure. So pressure natin, merong binigay na pressure. Yung na-solve natin, no, yung sa water hammer, kasama yan sa kailangan nating ilagay. So that is in terms of kilopascal. Tapos idagdag natin yung pressure na static pressure. So that is gamma H. No, that's 9.81 times yung head ng tubig, that's 350. So 9.81 times 350. So yan yung total pressure. Again, yung static pressure head plus yung pressure dahil sa water hammer. Divide natin sa twice ng thickness natin na 18 mm. So what is the value of the maximum stress acting on the pipe? So baka magtaka kayo, sir, ba't hindi yung P over 40? So if you're going to compare the values, syempre mas maliit yung P over 40. Di ba po? So sigma sub T. Tensile stress yung mas malaki. Sige, sana po yung sagot. So maximum stress is 198.944 kilopascal. Sige, take a screenshot if you want. You can take a screenshot. Ay, tama. Wala, hindi ko pa nalagay yung diameter. Sorry. So, what is the diameter? So, kailangan pa natin i-multiply sa 600, no? So, 3728.484 plus natin yan sa 9.81 times 350. Wait lang. Let me get my calculator. Ano yung magiging sagot if i-multiply natin yung diameter? 3728.484 plus 9.81 times 350. 2 times 18. So, yung diameter, multiply natin. That is 600. No? So, that's 119. Lagay ko muna yung diameter, ha? So, times 600 to. Okay, so answer would be 119,366.4 kilopascal. No? So, makakancel lang yung millimeters dyan. Analyze natin. So, dito, sa pressure, di ba, this is ang 3728 na kilopascal to, kPa. Ayan, itong 9.81 times 350, yung 9.81 kilonewton yan eh. So, kilonewton, ibig sabihin kPa din to. Kilonewton per cubic meter times meter, so you have kilonewton per square meter, that's basically kilopascal. Ang unit dito, naka-mm. Sa baba, naka-mm. So, since naka-product yan, pwede mo yung i-cancel. Bale, yung sagot natin, naka-kilopascal po. 119,366 kilopascal. So, yan yung sagot natin for letter C. Sige, take screenshot. Another questions? Padlet? Walang questions. Padlet? Wala na. So, may nagtanong, good morning sir. Ano po reference book nyo sa hydraulics? Salamat po. So, usually si ref tsaka yung libro ni Sir Gili na hydraulics. Fluid mechanics hydraulics. Sige, so wala na po bang tanong tungkol sa problem na to? Goods na po. So tungkol sa tanong na hindi po ba in terms of meters, pwede naman i-convert. Pero ganun rin, no? Magka-cancel. We'll have the same answer. Pastboard yan, sir, na problem. Ito, hindi. Hindi to pastboard. Sir, bakit po rapid sa part 2? So, bakit rapid? So, meron kang hint sa tanong na quick closing. Quick. So, ibig sabihin ng quick, rapid. Assume mong rapid siya. Pag sinabi niya ang quick. I think okay na. Wala nang tanong, no? Tungkol dito. Sir, pwede po ba sabihin na yung minimum stress is yung longitudinal stress? Ano ba yung framing ng question? What is the... yes. Minimum stress would be the longitudinal. Kasi yung pressure dyan, sa formula natin, that is internal pressure. No? So, wala namang ibang nagkakos ng ano dyan, ng ang tawag dito, stress, kundi yung ano lang, internal pressure. Sir, what if in the problem it's not stated whether the pipe is rigid or non-rigid? By default po ba is it's non-rigid kapag walang naka-state? Pag walang naka-state, rigid. Kasi yung common natin na gamit is rigid. Diba? Sa mga pipe connections. Pero ibibigay naman yan. Isi-state naman. Kasi magkukos yan ng confusion sa mga mag-take. Sir, if TC equals to LC, ano po yung gagamitin na formula? Kung mag-equal sila, rapid pa rin yun. Ano pa? May tanong pa tungkol dito. Yan na po. Sige, so let's move on. I hope na clear itong lesson natin yan. Okay, so before we go to break, so let's review no what are the concept and formula for orifice. So this is both steady and unsteady flow. Okay, so first and foremost, ano bang ibig sabihin ng steady flow? Ayan, so pag sinabi po nating steady flow, ibig pong sabihin no na yung head or yung height ng tubig, let's say sa isang tangke or isang chamber, is constantly maintained. Hindi siya bumababa. Okay, so constant yung head ng tubig natin. Yan po yung ibig sabihin. So just to review, no? Let's say we have an ideal flow or ideal energy. So ibig sabihin walang head loss. So expand natin using yung formula natin ng Bernoulli energy equation. So at point A, of course, meron tayong ano dyan, no? Velocity head. And then dito sa point A, dito sa chamber A, so ang point A natin, 'di ba, is acting or it is at a point no that is h meters below sa surface. So ibig sabihin merong pressure po dyan caused by the weight of the fluid, and that would be pressure at A plus gamma H. So pressure ng hangin plus yung gamma H dito. That's the pressure caused by the weight of the fluid above point A. Divide na natin yan sa gamma. Okay? And then since yung point 1 tsaka point 2 same elevation lang, so that is 0. Equals, of course, may velocity din sa point 2. Plus yung ating pressure head sa B that is caused by the pressure at chamber B plus 0 kasi same lang sila ng elevation. So ito na ngayon yung formula ng velocity natin. Okay, velocity at point 2. No? Diyan sa tubig na lumalabas galing sa orifice. Yan po yung velocity natin. Okay, so bale yung total head po, no, sa formula na alam natin, yung total head is equal to, ayan. So yung velocity head dito sa point A, okay, plus yung pressure at point A, pressure head, no, plus yung H natin, that is galing yan dito, no. Bale yung PA plus gamma H over gamma, pinaghiwalay lang sila. So P over gamma plus gamma H over gamma, that's H. Then minus pressure at B over gamma. So yung alam natin, no, na H na formula, 'di ba? Sometimes we just simplify it, that is simply the height. Okay, so hindi lang po siya yung height ng ano natin, tubig, no, from the orifice to the surface, no. But rather it is also affected by the velocity dito sa chamber A. Ayan, plus yung pressure head chamber A plus yung height, and then babawasan mo siya ng pressure sa chamber B na nasa labas. So of course kapag open yan, 0 lang yan. Yung total head magiging ano na lang, VA squared over 2G plus P over gamma plus H. Okay. So, yung na-derive natin na formula kanina, itong V is equal to square root of 2G, tapos ipalit mo itong buong to, palitan mo lang siya ng H. So, it's going to become VT square root of 2GH. So, yan yung theoretical velocity natin. Okay? So, now yung actual velocity naman, so you just multiply that with the coefficient CV. Okay? So, pag sinabi natin CV, that is the coefficient of velocity, ratio lang po yan ng actual over theoretical. So, yung coefficient na CV, that is, purpose niyan is para ma-take into account no, yung mga different na mga factors that might affect the theoretical velocity. No? So, magkakaroon talaga ng slight na pagkakaiba from the actual measurement tsaka yung sa theoretical measurement. So, yung nagko-correct dyan is yung coefficient of velocity. So, yan po yung purpose. Next, we have here the discharge. Ayan. So, itong theoretical velocity, kapag sinubstitute siya sa theoretical, yung formula ng discharge, diba? Q is equal to AV. So, palitan mo lang yung velocity ng square root of 2GH, meron ka ng formula ng theoretical discharge. Okay? So, kaya area, so itong area dito, that is area of the orifice po yan. Okay? Kasi sa orifice, lumulusot yung tubig natin, di ba po? So, area orifice, square root of 2GH. Ayan. So, yung actual discharge naman, if we take into account no, yung coefficient, so, tingnan natin, ito yun. Explain ko lang paano natin na-derive yung actual discharge. Okay, so ito yung sinasabi kong area of orifice. Ayan. So, yan po yung butas makikita natin sa orifice. No? Okay, so tatawagin natin siyang area capital A. Now, at a distance na approximately equal sa radius nitong butas sa orifice, so that would be a distance of d over 2. No? That is the diameter of the orifice divided by 2. So, we will find no, the position of the vena contracta. Okay, so yung vena contracta po, okay, yan po yung circular cross-section no, ng jet paglabas niya galing sa orifice. Okay po. So, we denote that as small letter A kasi mas maliit siya compared doon sa area, cross-sectional area ng orifice natin. Okay, so again, the area at the vena contracta is small letter A. So, yung actual discharge, if we are going to have the ratio of the area, cross-sectional area of the jet at the vena contracta, divide natin sa area sa orifice, yan po yung tinatawag natin coefficient of contraction, CC. So, if you cross-multiply this one, CC times A, you'll get the area of the smaller or of the jet, no? Area of the jet. That is the area at the vena contracta. Now, if we're going to compute no, the Q or the discharge at the vena contracta, that is going to be equal to area times velocity. That's area of the jet at the vena contracta. So, substitute mo lang yung CC times A dito sa small letter A natin. So, So that's CC times A times yung actual velocity natin. That's CV square root of 2GH. Now, itong CC times CV, yung product po niyan, that is actually equal to C. So mayroon siyang relationship. So yung C po, that is equal to CC times CV. So ito, papalitan natin yan ng C. So yung formula natin magiging C and then times yung A po dyan, that is the area of the orifice. Okay. So ito na yung Q actual. Okay. So ito na yung summary ng lahat ng formulas natin. Okay, paki-screenshot if you want. So take note ko lang, this is area orifice. Okay, sub O. Okay po. And then, yung head loss naman, so let's say, if you're going to consider the roughness of the orifice material, ayan, so, if naalala nyo yung formula for head loss for minor loss, di ba ano yun? V squared over 2G times yung K coefficient. Di ba po? So, for this, ang magiging K coefficient natin is ito, no? This 1 over CV squared minus 1. In this particular, so hindi siya, strange na formula. Ano lang siya. Same lang din siya sa minor loss ng pipes natin. Bali yung K niya in terms of the coefficient of velocity. So since nasa denominator yung coefficient of velocity, so pag mas maliit yung coefficient of velocity, so ibig sabihin na siya, inversely proportional siya sa loss, head loss natin. Okay, so yan lang po yung formula ng pagkuha ng head loss. Kuha po ba? Okay, so take a screenshot of the formula. In 1, 2, 3. Okay, so ito yung mga device coefficients natin. So for coefficient of discharge, ratio po siya ng actual Q tsaka yung theoretical Q. And then coefficient of velocity, yun pa rin, no? Actual over theoretical velocity. Coefficient of contraction, that is the ratio of the area of the jet over area of the orifice. And then relationship ng CC tsaka CV, so if you multiply that, yan yung ating C, coefficient of discharge. Okay, and then tandaan lang po natin, no, kapag open yung tank, again, this is steady flow. So ibig sabihin nun, Even though may lumalabas na tubig dyan, so constant pa rin yung yung inflow ng tubig. Okay, so if uh, ganito yung hitsura ng ano natin, orifice, let's say nasa baba lang siya. So yung magiging head natin is simply the height of the water, initial height of the water. Now, when there is acceleration involved, no, hindi ko na lang to i-derive yung formula kung saan to galing. But yung head po, that is simply the head or yung height ng tubig, kailangan po natin siya i-multiply sa 1 plus and minus a over g. That is acceleration over the gravitational acceleration. And then if closed naman po yung tangke, so we just have to take into account the height of the water or the liquid times gamma h. Sorry, P over gamma, that's the pressure head. So again, that is total head is equal to height of the water times or of the liquid times or plus pressure head. So bali idadagdag mo lang sa height yung pressure head. Sige, so let's have a 30 minutes break. So we'll be back by 10:20. Okay? To solve a lot of examples about orifice. So you don't wanna miss it. Sige, so see you later after 30 minutes. Now let's continue. Dinig naman po yung audio ko. Can you hear me? Dinig naman po yung audio. Ayun, meron. Sige, so let's continue. Okay, so first problem natin. Problem 26. So, we have here constant head. So, ibig pong sabihin ng constant head, bale, meron tayo ditong tank, tapos may discharge, no? Dito sa hole. Okay, dito sa may orifice. But then, the height of the liquid is maintained. So, most likely, no? Even if merong Q out, so patuloy pa rin yung pag pasok ng tubig dito sa system. No? Kaya hindi nagbabago yung head ng ating liquids. Okay po. Sige, so let's read the problem. So an open cylindrical tank, 2.4 meters in diameter and 6 meters tall, has 1 meter of glycerine with specific gravity equal to 1.5, 2.5 meters of water, and 1.5 meters of oil. So, binigyan din tayo ng specific gravity ng oil, that is 0.82. Determine the discharge through the 125 millimeter diameter located at the bottom of the tank. Okay, and then binigyan tayo ng C, coefficient of discharge, that is equal to 0.65. Okay, so as you can see, sa figure natin, meron tayo ditong tank. So, at the sa pinakabababa no, na level, that's your glycerine with height 1 meter. And then, you have here water that is 2.4 meters in height. And then, yung oil natin, 1.5 meters. Okay. So, ano yung formula natin to find the discharge through the hole? Is it the theoretical discharge or is it the actual discharge? Okay, so in this case, since yung ating tanong is kung ano yung discharge through the orifice, no, di ba? Sabi dyan, through the 125 mm diameter hole. So, ibig sabihin, we are solving the actual discharge. Okay po. So, that is Q is equal to the C, the coefficient of discharge, times the area, so area of the orifice po yan, times the square root of 2 times G times H, or which is the head. Now, if you notice, yung layers ng ating liquid are different from each other. Okay? So, kapag po meron tayong problem na iba-iba yung layers ng liquid, so yung head po natin, hindi po pwede na i-add mo lang lahat. No? Yung 1, 2.4, 1.5. Kasi po, ang assumption dito sa formula na to is isa lang yung liquid. Okay? So, ang magiging approach po ng solution natin is convert natin lahat ng liquids natin into the same liquid that is at the orifice that is already discharging. In this case, glycerin po. No? So, bali yung water, convert natin to glycerin. Yung oil, convert natin sa glycerin. So, paano po yan gagawin? Okay, so that is simply equal to H, no? That is H due to glycerin plus H due to water plus H due to oil. Okay, so again, ang goal natin is convert natin silang lahat as glycerin. Okay? So, start tayo with the head of glycerin that is 1 meter. Tapos idagdag lang natin no, yung height muna ng water. So, that is supposed to be 2.5. So, dapat 2.5 yung given natin. Hindi ko na bago. So, that is supposed to be 2.5. Okay, for a while. 2.5. Okay. So, next is yung height ng ating tubig, no? I-multiply ng water. Multiply lang po natin yan saan? Okay, sa ratio po ng specific gravity ng water over yan, over sa uh, specific gravity ng glycerin. Okay? So again, that's the height of the water times the ratio of the specific gravity of water over the specific gravity of your oil. So galing yan sa formula na S1H1 equals S2H2. No? So bale, divide mo lang or yung ratio ng ating ano, kita ko. Medyo naglalag yung PowerPoint. Ayan, so S1 H1 equals S2 H2. So divide mo siya by ano, Let's say you want to know the equivalent height. Divide mo siya by S1. So that's going to become H1 equals S2 H2 over S1. Okay, so let's say equivalent height of water. No, so bale, yung multiply natin dito is yung height ng water, 0.5. Tapos yung specific gravity niya. Let's say this is water dito. And then sa kabila yung glycerin. And then we want to know the equivalent glycerin height of water. So divide mo siya specific gravity ng glycerin. Divide mo siya by 1.5. Sir, paano po malalaman na yung problem is at constant head? Sa framing ng question, may kapag mas obvious yung yung hindi constant, no, yung varying yung kanyang head. So mamaya makikita nyo, merong specific framing yung question na sasabihin niya na how much time for the water or let's say the fluid to drop. Something like that yung mga tanungan. So kapag walang sinabing nagbago yung height, so that is constant head. Okay, plus equivalent height ng oil. So ganun pa rin, no? Specific gravity ng oil times height ng oil natin. Height ng oil natin is 1.5. Specific gravity ng oil, that's 0.82. Divide lang natin siya sa specific gravity ng glycerin, that is 1.5. So we'll get the total head, no? In terms of glycerin. So what would be the value of H? So bali yung H natin is equal to 3.487. Okay. So now na meron na tayong H, pwede na nating i-substitute doon sa general equation natin. So do we have C? Okay, meron tayong C that is 0.65. Substitute natin. Meron ba tayong area of the orifice? So I think given yung diameter ng orifice, so that's 125 or that's 0.125 in meters. So area lang ng circle, no, that's pi over 4 times diameter natin na 0.125 squared. Ayan. And then square root of 2g. Substitute lang natin yung 2 times yung g natin na 9.81. Tapos yung h natin na 3.487. So, ano yung magiging value ng q natin? Okay, our Q would be 0.066 cubic meter per second. So, yan na po yung sagot sa tanong. No? That is the discharge in terms of cubic meter per second through the 125 mm diameter located at the bottom of the tank. Okay, so any question about this problem? Check ko lang yung Padlet kung may mga questions ba lang. Sirs, time to empty the tank. Mamaya, sasolve natin yan. Constant head pa lang po tayo. So kapag mga ganyang tanungan, hindi na po yan constant head. Sir, sorry, hindi ko po nakuha. Bakit sa water po na multiply yung SG ng glycerin? So, yan nga po, no? Meron tayong relationship between specific gravity and height. I don't know if na ano nyo to dati sa laboratory nyo. Ulitin ko ah. So, yung equation natin is ganito, no? So, yung product ng specific gravity ng first fluid times yung height ng second fluid should be equal to the specific gravity of the second liquid times the height of the second liquid. Okay po. And then, let's say, yung first liquid natin, yun yung glycerin. Yung second liquid natin, water. Tapos, yung gusto nating malaman, ano yung equivalent height ng water? Or anong equivalent height sa glycerin ng water? So, to do that, divide mo lang to by S1. So, bale, yung height, equivalent height ng tubig in terms of glycerin is equal to the height of water, multiply mo siya sa ratio ng specific gravity ng fluid over specific gravity ng glycerin. Kaya, dito sa itong term na to, so itong 2.5, that is the height of the water, 2.5. Ito yun, H2. And then, multiply mo siya sa specific gravity ng tubig, that is 1, over specific gravity ng glycerin, that is 1.5. Do you follow? So, ito lang po yung formula natin. S1H1 equals S2H2. Good morning, sir. Mahina po yung audio. Is it still mahina? Okay, so yun lang po yung gagawin, no? Kapag iba-iba ng liquid yung, di ba, yung layers na binigay sa problem. So, convert mo lang using yung formula na S1H1 equals S2H2. let's proceed. Okay, so ito, problem na to, explicit na sinabi niya na mayroong constant head. Yan. Okay, so sabi dyan, an orifice having an area of 0.00982 square meter is attached to a vertical side of a cylindrical tank. So, nasa gilid, no? So, yung tank daw na yun, merong diameter na 4 meters. So, we're given the weight. So, I think I can show the figure. Ayan, so yan yung tank natin. So, merong butas sa gilid. So, of course, pag may orifice, pag may butas, may lalabas. Not too big. Okay, so the weight of the water discharged in 1 minute and 36 seconds is 22,571 under a constant head of 1.2 meters. So, may constant head daw na 1.2. So, yung constant head po na yan, always measured po yan from the orifice hole, or from the cut of the orifice to the surface of the liquid. Okay? As illustrated in the figure. And 1.92 horizontally from the vena contracta, and then 0.8 meters vertically below the orifice. Ayan. So, lagyan ko lang ng platform para kunyari nakaangat siya. Okay, so bali ganyan po yung nangyayari sa problem. Binigyan lang tayo ng weight flow rate. So, we're asked to find the coefficient of velocity, the coefficient of discharge, and the coefficient of contraction. Okay, so tatlo po yung hinahanap sa problem na to. Okay, so una po natin gagawin, indicate ko lang na yung point 1 natin is yung orifice, point 2 po is yung point kung saan pupunta yung tubig, no, sa after or following a path of a projectile. So yung point 2 dyan po dyan aabot yung tubig, no? Okay, now sa ganito pong klase, no, na projectile na figure, so yung velocity po dyan, no, sa point 1, wala po yung vertical component, no? So purely horizontal component lang po yung meron dyan. So bakit sir walang vertical component? Wala pong vertical component kasi as you notice, no, wala siyang ang nagko-cause lang ng hindi siya tinuslow upward eh. 'Di ba? Bale ano lang siya. Kung trino siya upward or at an angle, probably meron. But in this case, since yung projectile natin, no, is just horizontal yung ano niya, bali perpendicular siya sa orifice, which is always the case po. Palagi pong perpendicular sa orifice yung projectile. So yun, no? Again, walang vertical component yung ating velocity. That is true, no, for projectile. So V1 is just equal to the horizontal. Yung horizontal component lang meron. And that is true for every part of this projectile, no? So, kahit saan man dyan sa projectile natin, palaging ang V is always lang horizontal. Okay? Kasi horizontal lang din yung translation natin. Wala tayong So, that is true for all points. Okay? So, yung vertical natin dyan is 0. Okay, so ano ba yung mga formula na tatandaan natin kapag yung naka-projectile yung motion ng ating tubig, no, na nanggagaling sa orifice. So first po is itong formula natin na common, no, distance equals velocity times time, or in this case that's x, that's the horizontal distance, equals the velocity times the time. And then we know this, no, from dynamics. So relationship ng y. So yung y dyan, yan yung height, no, upon which a body will fall. So vertical height y is equal to the velocity, the vertical component velocity times time, minus 1/2 gt squared. And then we also have v2y squared equals v1y squared minus 2gy. And then yung pang-apat na formula, pwede natin siyang ma-derive, no? So we'll start with expressing the first equation in terms of time. So divide both sides by v1x. So you'll have t is equal to x over v1x. Okay, now if we substitute that dito sa second formula natin, so diba that's y equals v1. Okay, so since that is y component ng velocity, considering, no, na meron tayong angle theta, so yung angle theta po, that is the angle of elevation ng ating projectile. In this case, 0 kasi horizontal lang yung ating velocity. And then, okay, so then itong time natin, itong t dito, no, substitute mo siya ng x over v1x. Kaya po ito naging x over v1 cosine theta. So, kaya cosine theta, no, kino-consider natin, let's say meron siyang angle, no, yung projectile. So, paano, kaya merong cosine theta. Minus 1/2 g, tapos yung time natin, yung x over v1x, ipalit din natin. Ayan. So, yung v1x, that is equal to v1 cosine theta. Okay, so in this case, v1 will cancel. Simplify natin. No? So, yung natira na lang is yung y equals x. And then sine theta over cosine theta, we know that to be tangent theta. And then minus, so yung g tsaka x squared, sila yung nasa numerator, divided by 2v1 cosine squared theta. So, yan po yung pang-apat na formula na pwede nating magamit to solve for whatever is unknown. Okay po. Okay, so tapos tingnan natin yung mga given. Okay, so for problem number 1, we're asked to compute the coefficient of velocity. Ayan, so in this particular stage of the solution, o tingnan mo lang isa-isa anong formula yung pwede natin magamit. So yung formula number 1, merong, ang hinahanap is coefficient of velocity. So obviously, hindi natin yan magagamit. Although, meron tayong x, pero walang binigay na time. Ang time lang na meron dyan is time for time for discharge. Yung pangalawa, y equals v1yt minus 1 half gt squared. Yung pinaka-comprehensive na formula, tingin ko is yung pang-apat. Check natin. Okay, so that's x tan theta minus gx squared over 2v1 squared cosine squared theta. So yung y natin dyan, that is negative 0.8. As you can see here. So bakit siya negative? Kasi downward yung ating flow ng tubig, kaya negative. And equals to yung x natin is yung distance covered by the projectile of the motion of the water or of the fluid. So that's 1.92 times yung tangent natin. So in this case, 0 po yung angle kasi horizontal lang yung ating V1. Okay, minus yung G natin na 9.81. Tapos yung X natin which is 1.92 squared over, okay, so yung V1 yung gusto nating malaman, V1 cosine squared, tas 0 ulit ang theta kasi wala naman pong angle yung ating velocity na naka-horizontal, yung kulay pula. So we can now solve for V1. After solving for V1, actual velocity, compute natin dyan. So hanapin natin mamaya yung theoretical velocity. So V1 is equal to 4.754 meters per second. So ngayon na meron na tayong V1, we need now to compute for the theoretical discharge. Or theoretical velocity, I'm sorry. So theoretical velocity, yan po yung CV, coefficient of velocity, times the square root of 2gh. So, substitute lang natin. So, yung V there is yung V1. That 4.754 is equal to, so yung CV natin, yun yung unknown, times the square root of 2g, that's 2 times 9.81, times, ano po yung magiging head ng tubig natin in this particular instance? So, obviously, that is 1.2. Yan po yung distance from the reservoir towards the surface of the water. And then you can now compute for the coefficient of velocity. So, ano po yung value ng CV? Okay, so ano po yung CV natin? So, CV is 0.98. So, unitless po, no, yung mga coefficients natin. Answer for letter A. Sige po, paki-screenshot. Sige, next, let's compute the coefficient of discharge. Tabihin muna natin yung value ng CV. So, coefficient of discharge po, that is Q actual over Q theoretical. So, first is, solve muna natin yung actual. So, yung actual, that is C times A square root of 2GH. Substitute lang po natin. However, we're also given the coefficient, we're given the weight flow rate. So, solve muna natin yung weight flux. So, yung weight flux, that is, if you remember, in our day 1, that's simply gamma Q. So, since this is water, so yung gamma natin is, of course, okay, so di ba ang weight flux, that is weight over, ano yung formula? Weight over time. So, that is 227, baliktad ko. 22571 dapat yan. Over yung 96 seconds, that is, nasa problem. So, ito yung magiging Q natin. Ito. 22751, discharge in 1 minute and 36 seconds. 1 minute and 36 seconds. Ilan lahat yan? Ilang seconds lahat? So, add lang natin, no? That's 96 seconds. Sige, solve na natin yung Q. So, yung Q natin is equal to, in terms of ano to, cubic meter per second. So, converted na siya. So, that's 0.02416 cubic meter per second. So, now that we have Q, so pwede natin siyang ma-substitute. Sa formula na Q equals CA squared of 2GH. So, yung Q natin, obviously, 0.02416. Yung area, again, that is area lang siya ng orifice. Okay, so substitute lang natin. Q, 0.02416. C, yun yung hinahanap natin. Yung area, given, 0.00982. And then square root of 2G, 2 times 9.81 times yung head. So, ano ba yung head dito sa problem na to? So, that is 1.2, no? Yun yung haba ng tubig from the orifice to the surface. So, we can now solve for the coefficient of discharge. Yes, tama. Dapat 571 yan. Okay, so solving for C, coefficient of discharge. Ano po yung sagot natin? Sige, solve po. So C is equal to 0.507. So yan na yung bagong value ng coefficient of discharge. Okay po. So galing lang siya sa formula ng Q actual. Yes naman po. So bale yung sa Q, hinugot lang natin doon sa mga given na parameters for weight flux. Okay, next. Okay, for the coefficient of contraction, which is the question for letter C, so again, tandaan mo lang po natin yung formula ng coefficient of contraction. C is equal to CC over CR. That's coefficient of contraction over coefficient of velocity. So that's yung naunang C, that is your coefficient of discharge. So directly proportional siya sa CC, coefficient of contraction, tsaka na coefficient of velocity. So substitute mo lang, yung nakuha natin yung C kanina, 0.507, equals natin sa CV na unknown times yung CV natin, which is 0.98. So what is CC? Okay, so CC is equal to 0.517. So again, it's unitless. Unitless kasi ano po yan? Coefficient lang yan. So yan na po yung sagot. No? First part, 0.98. Sa C, 0.507. And then yung coefficient of contraction niya, 0.517. 0.517. Okay po. So, any question on this one before we proceed sa susunod? So itong next na tanong natin, this is from a past board exam. So sabi dito, a jet is issued from the side of a tank. Ito yung jet natin. Yan. With a constant head of 3 meters. So pag head po, tandaan palagi, always measured from the orifice and then towards the surface of the liquid. Ayan, so the side of the tank daw has an inclination of 1h to 1 vertical. So ibig sabihin po, yung angle of inclination ng tank natin is 45 degrees. Ayan. So the total depth of the water in the tank is 6.7 meters. So lagay natin. Neglecting air resistance and assuming coefficient of velocity is 1.0, so we're asked the following. So again, ano pa rin to ha? Steady flow. The maximum height to which the jet will rise, the point it will strike a horizontal plane 1.2 meters below the bottom of the tank. Letter C, the velocity of the jet as it strikes the ground. So, may tanong si John Riel Salcedo, sir, may figure po ba yan? Sa board exam, wala po, wala pong figure. Walang sinabing as shown. So you have to figure out no yung figure natin by yourself. So in this case, one horizontal to one vertical. So of course that's 45 degrees. Okay po. Sir, anong year po yan, sir, na board exam? Di ko ma-pinpoint anong specific, pero nasa CEREF, ano siya, CEREF 4. So it's a recent board exam question. Sige, so if in case na hindi siya one horizontal to one vertical, kunin mo lang yung arctan, no, for the angle. In this case, arctan 1/1, that's 45 degrees. Yeah. Sige, next. Letter A, the maximum height to which the jet will rise. So, the maximum height to which the jet will rise. So, yung jet po na yan, o yung rise ng jet, always measured po yan dyan po sa orifice, dyan sa point 1. No? So, yung maximum height is hindi siya measured from the ground. But rather, it's measured from the orifice. Kasi initially, yung pinanggalingan ni ang tawag dito ni jet is galing kay point 1 sa orifice. So ibig sabihin, ang height na tinatanong sa A is relative sa point 1. Okay, so yung point 1 natin is yung mismong orifice. And then yung point 2 po natin is yung height. And then consider natin as point 3 kung saan bumagsak yung ano natin, no, tubig, yung jet. So ang tanong is ano daw yung Y? Okay? Okay, so first consider muna natin yung velocity ng jet natin. So yung velocity po, that is always perpendicular from the orifice, no? So, with respect sa horizontal, since ano yan, no, naka-incline yung angle natin measured from the horizontal. So, if 45 po yung nasa baba, kita ko lang Di ba 45 yan? So, ibig sabihin 45 din to. No, by virtue of two parallel lines cut by a transversal, so yung alternate interior angles are equal. Tama. So if that's 45, it also follows that this one is also 45, correct? Kasi itong velocity na yan, perpendicular yan eh. So it follows na 45 degrees din yan. Hope that's clear. Okay? So 45 degrees po yan. And then ito yung mga formula na gagamitin natin to find for the value of y. Obviously, yung first one, hindi natin yan magagamit kasi wala naman yung y. So, ano na lang, no? Yung second, third, tsaka fourth question na lang. Okay, so how do we know? Depende sa mga given. So, in this particular problem, ang gagamitin natin is yung v2y squared equals v1y squared minus 2gy. And you can explore all the other two formulas, no? Kung pwede ba sila gamitin or hindi. But for this example, okay, yung y natin can be solved from equation number 3. Okay, so in this particular case, yung v1 natin is yung velocity at point 1. So, solve muna natin yan, no? So, yung velocity at point 1, that is the actual velocity. That is CV square root of 2GH. Binigyan naman tayo ng CV na 1. And then, ano na lang, square root of 2G. That's 2 times 9.81. So, ano yung magiging H natin? So, yung H natin is measured from the orifice to the surface. Ito po yun. That is 3 meters. So, we'll get a value of V1 as, ano po yung value ng V1 natin? So, V1 is 7.67. Tama po ba? Okay, 7.67 po yan. Next is plug in natin, no? So, isa-isahin muna natin. So, tanong, meron ba tayong V2Y? Okay, so in this particular example, no? 0 ang V2Y natin. Ayan, so bakit 0? Kasi umabot na siya sa tuktok ng projectile. No? Ibig sabihin wala nang vertical component yung velocity. So wala siyang choice. Yung motion niya is only affected by the horizontal component of the velocity. Hindi na siya umakyat. So ibig sabihin 0 yung v2y. So 0 squared equals v1y. Okay, so that is the y component of the velocity 1. So that would be V1 cosine, no? I'm sorry, sine kasi vertical. 7.67 sine 45 degrees. Tapos squared lang natin yan. Minus 2g and then ano yung y natin? Yan yung unknown. So we can now solve for y. May 2015. Okay, thank you. Si RF4. No, recent lang siya. Okay, so yung y po natin is equal to 1.5 meters. Okay po. Yan po yung sagot sa letter A. By the way, itong second equation, wala tayong given na time, no? Kaya, hindi siya viable na formula for this question. Yung pang-apat, hindi rin kasi wala pang x. Wala pang horizontal tawag dito, translation. So yung pwede lang talaga for question A is itong v2y squared equals v1y squared minus 2gy. The rest are not possible to be used kasi walang given. Ayan. So, any question po for the part 1? Next, letter B. The point it strikes a horizontal plane. So, this time, meron na tayong x, no? The point it strikes a horizontal plane 1.2 meters below the bottom of the tank. Naulit lang to yung kanina to. Ito. So the point it strikes a horizontal plane 1.2 meters below the bottom of the tank. So ano daw yung point na yung point 3 daw, no? Anong distance niyan? Okay, so sabi dyan, 1.2 meters below the bottom. So, nilagay natin yung 1.2. So, yung nahanap yung x, no? Ayan, yan yung inahanap. Pero binigyan tayo ng vertical translation, 1.2 meters. Okay, so alin sa mga formula yung pwede natin gamitin? Ayan, so obviously yung merong x, no, na formula. That's y equals x tangent theta minus gx squared over 2v1 cosine squared theta. Okay? Sige, so substitute. Ano po yung magiging y natin? Okay, so remember na yung drop starts from the orifice, no? Kaya 4.7 plus 1.2. Okay? So galing dito. Pababa. Yan. So that is 3.7 plus 1.2. Ang sagot is negative 4.9. Okay po. Sir, bakit negative? Kasi pababa po yung translation. And then, equals x na unknown. And then yung angle, that is the angle of inclination, no, of the jet with respect to the horizontal. So that's 45 degrees. Ito po yung angle na yan. Ito. 45. Hindi ito. Kasi pwede itong magbago eh. Pwede itong maging 30. Pero yung angle dito, yung theta, dyan sa formula. So, minus, yung G natin, that is 9.81 times x squared over twice the velocity at 0.1, 7.67 squared times cosine squared 45. So, saan galing yung 1.92? So, dapat wala yan. Unknown yan. Sige, pakitry nga pong isolve. Check ko na rin sa... Okay, so dapat x to. Wala tong 1.92. Sige, so the value of x would be, ano po? So x is equal to 9.19 meters. Answer for letter B. Next, letter C. The velocity of the jet as it strikes the ground. Okay, so ang formula lang po dyan is x equals v1x times t. Okay, so yung x natin, na-solve na natin kanina, that is 9.19. times yung velocity. Solve natin kanina, that's 7.67. Okay, and since it's x component, that's of course cosine 45. And then yung t natin. So t would be just equal to 1.7. So I think the question there is supposed to be the time that it takes, no, for the jet to touch the ground, in the velocity. The answer for question C, no? The time for the jet to strike the ground is simply 1.7 seconds. Okay po. Next. Sige, so tapos na tayo sa steady flow. Ngayon, we'll consider unsteady flow. So for unsteady flow, ang ibig sabihin lang po niyan is yung tubig natin as it goes out or as it comes out from a container or from a tank. No? So wala nang nag-fill in na water or any liquid or fluid to sustain the height of the reservoir para maging steady. So bale, bababa na yung tubig natin. No? So bale, Q out na lang, wala nang Q in. Now in this analysis, we'll consider AS. This is the surface area of a container. And then we will also consider a differential strip, the center that with height DH and surface area AS. Okay, and H2 is, H1 here is the initial height. And then after some time, bumaba yung tubig no, naging H2. Okay, so there are two possible scenarios aboard the exam. So first is when the area is varying. Ibig sabihin, yung cross-section area is not uniform. So for example, pyramid or mga cone, some of a cone, mga ganyang area ng container. So to start the derivation, no, we'll start with equation Q is equal to velocity times time or velocity over time, diba? So yun yung alam natin for discharge na isang formula. Now, if we are going to consider a differential volume with respect to time, no, and then cross multiplies, we'll have dt equals dv over q. Now, if we integrate both sides, so the time, no, would simply be, so ano ba yung differential volume natin? So that is, of course, surface area times yung dh natin na negative over yung ating q. That is from height 1 to height 2. So, bali with respect to dh. So, kaya yan negative, no? Kasi pababa, no, yung ating height. Now, para maging positive yung dh, so that babalik na rin lang natin yung limits ng ating integration. So, that's ASDH. And then yung Q, pinalitan lang natin ang formula for actual discharge. That's CAO square root of 2GH. That is from H1 to H2. So, bali, ito na po yung time that it takes, no, for a liquid or for a fluid, no, with an initial height, H1, para siya ma-empty into H2. Okay? So, tabi lang muna natin yung formula. How about when area is constant? So, actually, pwede natin gamitin, no? Yung mismong integration for both constant and hindi constant. But the formula for when an area is constant is simply, ayan, no? So, since constant na yung area, lalabas lang natin siya sa integration. Together with all the other parameters that are constant in this equation. Kaya lumabas tong AS natin. So, AS over C coefficient, that's the coefficient of discharge, area of orifice, square root of 2G. All these things are constants. So, yung natira na lang sa equation natin is yung hindi constant. So, yung height, of course, magbabago. DH. Okay? So, sir, saan galing yung H negative 1/2? So, di ba may natira sa denominator na square root of H? So, in-express lang natin siya into negative exponent para hindi na siya maging fraction. Okay? So, integral ng H raised to 1/2. So, that is 2H raised to 1/2. And that is from H1 to H2. Or that is 2AS over C times area of orifice of square root of 2G times the square root of H1 minus square root of H2. So, ito na po yung magiging formula for time if area is constant. Okay po. So, when area is varying, ASDH over coefficient of discharge times the area of orifice times square root of 2GH. The area is constant, so that's time is equal to 2 area surface area, over C coefficient times area of orifice times square root of 2G times square root of H1 minus square root of H2. Now, let's say you have two tanks that has the same uniform cross-sectional area. So, let's say cylindrical would be a good example. AS1, AS2 are not necessarily equal but same sila ng uniform yung cross-sectional area ng tangke. So, the time, no, that it would take, no, for H1 for the two liquids to be at a certain height 1 and height 2. So, that would be AS1 times AS2 over AS1 plus AS2 times 2 over CAO square root of 2G and then square root of H1 minus HF2. Okay po. So, bale, yung nabago lang, if you notice, ito lang AS. So, yung AS, napalitan lang siya ng AS1, AS2 over AS1 plus AS2. All the rest, 2 over CAO square root of 2G times quantity square root of H1 minus square root of H2 are all the same. So, madali lang siyang tandaan in that way, no? Na yung nagbago lang for area constant and for tanks with uniform cross-sectional area is essentially yung value lang ng AS. So let's try to solve this problem. So a 1.5 meter diameter vertical cylindrical tank, 3 meters high, contains 2.5 meters of water as seen in the figure. And then a 100 mm diameter circular sharp edge orifice is located at its bottom. You're given the C coefficient. So how long will it take to lower the water level to 1 meter deep after opening the orifice? And then how long will it take to empty the tank? So kapag how long po na question, ibig pong sabihin nito na falling head na po, no, yung ating orifice. Hindi na po siya static or constant yung head, no? Kasi meron ng pagbaba ng water level na makikita natin sa framing ng question. Okay? So let's deal with the first question. So how long will it take to lower the water level to 1 meter deep after opening the orifice? So ito lang po, no, the time to lower the water level to 1 meter deep. Ito lang po yung formula natin. So 2AS. Since this is constant yung cross-sectional area, so yung formula natin for time is yung constant din yung cross-sectional area. So yung 2AS over C coefficient area orifice square root of 2G times quantity square root of H1 minus square root of H2. So isa-isahin natin, no? Sige, so yung time, okay, 2 times, so ano yung magiging surface area natin? So in this case, that is simply the area of the, di ba given yung 1.5 na diameter? So area lang yun ng circle. 5/4 times 1.5 squared. Over, okay, yung C coefficient natin na 0.6. And then area of the orifice, so area lang yun ng circle. Diba? That's 100 mm in diameter. So that's 5/4 times 0.1 squared times the square root of 2G. No, that's 2 times 9.81. So yung crucial dito is alam natin paano yung H1 at H2. So tanda natin yung H1, yan yung initial, no, na height ng tubig before nangyari yung pagbaba. So in this case, what is the initial height? So obviously it's 2.5, no? How about H2? So yan yung final height na gusto mong malaman. So in this case, 1 meter deep na lang. So 1 yung magiging H2 natin. So you can now solve for T. So you try to solve for T. So yung value ng time natin is, are you still with me? Time natin is 98.4 seconds. Okay. Did we arrive to the same answer? Tama naman po. Walang reaction, so I guess it's correct. Okay. Naka-private ang live? Paano naka-private? But others could still watch the live. Am I right? Okay, next. So, yung merong alternative solution, no? So, for this kind of problem, so pwede tayong gumamit ng formula ng integration para hindi ka na maraming formula na isa na lang, no? Yung formula ng integration, and that is supposed to be for uh, hindi uniform yung cross-section. So, pwede din siya gamitin for uniform. Para yan na lang yung tandaan mo. Okay? So, plug in mo lang yan. So, that's pi over 4. Area ng surface, diba? Pi over 4 times 1.5 squared over, so, actually, pareho lang siya talaga ng mukha, no, sa mga values natin sa first natin ng solution. So, ayan, may area ng surface, pi over 4, 1.5 squared. Tapos, may 0.6 na C, and then area ulit ng orifice, pi over 4 times 0.1 squared, times the square root of 2gh. Yung g dyan, palitan mo lang ng 9.81. So, what is T? So, our T is still the same na 98.4 seconds. And then, question letter B, how long will it take to empty the tank? So, time to empty the tank, same formula, same values. Yung babago lang is yung H2, no? So, that's 2 times area pa rin ng surface, pi over 4 times 1.5 squared. C coefficient natin ng 0.6. Area of orifice natin, that is pi/4 times 0.1 squared. Square root of 2g natin is square root of 2 times 9.81. Then times, so initial height 2.5 square root. Then minus final height, that is 0. So what would be the time? Sige, so tuloy lang natin. So time is simply equal to 267.72 seconds. Okay? So yung alternative solution dito is ganun pa rin, no? Integrate mo pa rin. That is ASDH over CO square root 2GH, H1 to H2. So yung nagbago lang dyan is, of course, yung 2 sa numerator, no? Yun lang yung nawala dyan. And then, of course, yung H1 at H2 sa right side. Okay, so ganun pa rin yung magiging sagot. 267.72 seconds. Next, let's have another example. So a tank with a frostum of a cone having its bases horizontal and axis vertical is 3 meters high and is filled with water. It has a diameter of 2 meters at the top and 1 meter at the bottom. C is given, that's 0.61. How long will it take to empty the tank from full capacity? So bigyan tayo ng diameter ng orifice which is 0.1 meters. Okay, so since this is an example of a container with no uniform cross-section, so that would be, ito yung formula natin. Integral of surface area over the C coefficient, area of orifice, that's the square root 2gh, from h1 to h2 with respect to h. So, sa pag-solve nito, kailangan lang natin mag-identify ng AS, no, or surface area at any point, no, but usually nasa in between, no, sa upper surface and the lower surface. So let's say yan yung point na napili mo. We'll call that the radius of that AS as x. Okay, tas yung height niya from yung head niya from the orifice, that is h. Then since 1 meter yung diameter ng surface sa baba, so that's 0.5 radius. Kalahati din ng diameter ng surface sa taas, that's 1 meter. Okay, so gagawin natin is project lang natin, no, yung vertically from the bottom, no, tong dulo ng 0.5 paakyat. And then we can have a triangle. Tapos gawa tayo ng relationship. So bali yung AS po, that is simply pi x squared, no. Gusto nating malaman ano yung magiging value ng x. So by virtue of similar triangles, pwede nating ma-solve si AS. So that is, okay, so itong itong 1 minus 0.05, no, yan yung base ng triangle. Bale, ito yan. Okay? So, di ba, that's 1. Tapos minus mo lang yung 0.5 na radius sa baba. So, you'll get the base of the triangle. Bale, tawagin natin siyang, for instance, A. So, ito yung A. Ito. Ang A yan, ha. Okay, over 3. Equals natin yan sa triangle ulit dyan sa baba. No? So, difference lang yun ng x tsaka ng 1. So, that's x siya ng 0.5. So, x minus 0.5 over yung h natin. That's the head of the supposed surface area. And I'll express this of h in terms of x, or x in terms of h. So, that's 0.5h plus 1.5 over 3. So, substitute natin yung x ng value. So, that's pi times yung 0.5h plus 1.5 over 3 squared. So, that would be our AS. And then, substitute natin doon sa pinaka general equation natin. That is integral of AS. Diba? That's pi times 0.5h plus 1.5 over 3 squared. Over 0.61. That is your C. Area of orifice. So, of course, area lang ng circle. Given yung diameter ng orifice, that's 5/4 times 0.1 squared. And then 2gh, the square root of 2 times 9.81 times h. Okay, tas yung ating limits is going to be 0 to, di ba? To empty from the full capacity. So, ibig sabihin, H1 mo is um, 0, H2 is 0, and then H1 mo, H2 is 3. So, H1 is 3, sorry. H1 is 3, that's the initial height. Tas 0, yan yung final na height ng ating tubig. Yeah, so you'll get a value of T. So, ano po yung time to empty the tank from full capacity? Time is 239.319 seconds. So, answer for problem 29. Okay, and then finally, our last problem, problem 30. So, again, this is orifice example for falling head. So, the figure describes the elevation of the water surface at the surface tube. So, given yung area ng surface, that's 0.004. And the C coefficient discharge, that's 0.6. So, you're asked what is the initial discharge. Okay, so yung formula natin is simply Q is equal to C coefficient or the coefficient discharge times the area of the orifice square root of 2GH. Ayan, so yung Q natin, so given naman yung C, that's 0.6, so substitute lang. And then yung area also given, that's 0.004. And then times the square root of 2G, that's 2 times 9.81. So, ang tanong, ano yung magiging H natin? So, yung H po natin is yung difference lang ng level ng height ng surface ng mas malaking tangke at saka ng mas maliit. Yan lang. So, in that case, di ba, 11 yung height ng tank 1, 1 naman yung sa tank 2. So, that's 11 minus 1, so that is 10. Okay po. So, times 10. So we'll now have the value of our discharge, Q. So Q is equal to 0.034 cubic meter per second. So that's the answer for letter A. Next question. So when will the water surface become to the same level following a quick opening of the tube? So for this question, so yung formula na gagamitin natin is ito. Ito yung formula natin for two tubes, no, that are uniform cross-section. Ayan. So, yung AS1 natin is yung surface area lang ng mas palaking tank, and then yung surface area to is surface area lang ng pangalawang mas maliit na tank. Tapos, masasolve naman natin yan. Kasi alam mo naman natin yung surface area ng tank 1 at saka ng tank 2. Okay, kasi meron naman diameters, di ba? Okay, so solve natin. T is equal to, so yung surface area ng pipe 1, so we'll just use the radius, yung pi r squared na formula, so that's pi times 4 squared for the tank 1. For the tank 2, that's pi times 2.5 squared, kasi lahati ng 5, that's 2.5, so that's the radius. And then, copy natin sa baba, AS1, that's pi 4 squared plus pi times 2.5 squared naman ang surface area 2 times 2 times yung C coefficient natin na 0.6. Area of orifice, that's given on, that's 0.004. 2G, that's square root of 2 times 9.81. Square root of H1, that's 10, di ba? That's 10. That's the difference between 11 and 1. Yung H2 naman natin is, kapag same level na sila, so ibig sabihin, kapag equal na, wala nang H, so that would be 0. So what would be the value of T? T is equal to 8,400.19 seconds. So that's the answer for letter B. Letter C, so when will the water surface be 4 meters apart? So again, same formula, same given. Ang magbabago lang is yung final H. The final H is simply 4. No? Kaya pinalitan natin yan ng 4 yung sa square root. So what is T? So time is 3,087.44 seconds. So that ends our discussion. So I'm open to your questions. If there are questions. We'll end in a while. Na-late kasi tayo kanina, kaya nagsan ako ng konti. And then please don't forget to send in advance your questions for the consultation. Thanks. Sir, sa alternative solution, unsay input sa square root 2gh? Sorry. Asa ani? Ano sa problem? Otobrata 1230 guys. Asa ani nga problem? Kani. Ang H, yung H walang value. Yung G meron ng 0.81. So bale, magiging in terms of H siya. Tapos input mo lang siya sa integral sa calculator. So, bali yung h, wala talaga siyang value. Kasi kung wala kang variable na h dyan, hindi masasolve yung integral. Okay. So, that's clear. Di na po makita live news, sir. Baka pwede pa makahingi ng link sa live. Say, are there any other questions po? Post nyo po ba ang PDF after? Yes, yes, yes. I will post. Immediately. Sige, so if wala na pong questions, so for this evening, I might start again my discussion with sa falling head kasi maraming naputol yata yung live for the others no, na hindi nakaka-catch up. And then please, yung questions nyo for consultation, type na lang dito in advance no, para matingnan ko kagad. Okay po. Sige, so if wala na pong tanong, you are dismissed. See you next week and then I will upload the PDF. Okay, good noon and ingat kayong lahat. Bye-bye.